In this section, we'll be looking at how to calculate the midpoint of a section, line section, and perpendicular bisector. We went through these skills briefly in the last chapter, in chapter 5, but I'll just make sure you understand them again. Here are some circle theorems. Although the book doesn't tell us, it's important that you remember these from your GCSE. Each and every one of these theorems is uh, an assumption that you can make at any point in any example question given to you. So make sure you review these, pause the video, and make notes for yourself. If you're not familiar with any of these, you should be familiar with all of this, and these are the assumptions that you can make given that you've been told you have a diameter in a circle, for example, or whether you have a tangent to a circle, and so on and so forth. So then, in reviewing the skills we learned in the last chapter, I went through the problem where you had to find midpoint of a line section. So we have two coordinates, and you have to find the coordinates of the midpoint. Here, you would just simply take average of x values and average of y values, and that would give you the answer 4, 6. In this next example, you are using abstract algebra to figure out the midpoint. So it doesn't matter, even though you don't have numbers, you can still add 7a to 2a. That would give you 9a. 9a over 2 is 4.5a, and so on and so forth. So if we put the numbers into the formula, or rather the expressions into the formula, you'll end up with this answer here. Now, in this next example, you've been told the diameter of a circle goes through these two coordinates, A and B. We've been told to find the center of the circle. The assumption is that the center of the circle is the midpoint of the diameter. You do know the endpoint for the diameter of the circle, so just if I label it for you, be something like so. The center of the circle is always the midpoint of the diameter. Okay, so basically apply the midpoint formula here, and we'll end up with 1,6. In this next example, you've been told that the diameter of the circle with center 2, minus 2 is PQ. We only know one of the coordinates P, and we want to know where is the other coordinate Q. So the picture of the question looks something like so. We want to know the coordinate of Q. So you have to work backwards with the midpoint formula. What's the midpoint formula? We know that 2, minus 2 is the answer to, when we took the average of, let's call the coordinate of Q xq over 2, and we know the y value for the midpoint is, let me put brackets around it so you don't confuse, and minus 5 plus y value of q divided by 2 is minus 2. So writing them separately, 8 plus x, that's the x coordinate of q, divided by 2 is a 2 here, this 2. Solving this for x is just one variable, one unknown here. Q is just indicating it's a subscript here. Alright, so multiply both sides by 2 and you get 8 plus x equals to 4. Take away 8 from both sides, so the x coordinate of q is minus 4, which makes sense in that quadrant. X is a negative. Now taking this equation, the y coordinates minus 5 plus y for q divided by 2 was minus 2. Multiply both sides by 2, you end up with minus 5 plus y equals to minus 4. So add 5 to both sides, yq is 1. And it makes sense because it's in the second quadrant. So q has coordinates of minus 4, 1. Let's look at the next example. So I'm going to give you time. You can pause the video, have a go at the exercise A for your information, and I'm gonna go through for exercise 6B. All right. In this section, we'll be looking for midpoints and perpendicular bisectors. So we've been told that a line AB is a diameter of a circle, and with center C, A and B have such coordinates, respectively, and line L passes through the center. So L is, in other words, is a diameter. We've been told to figure out the equation of this line. So first we need to figure out the gradient of the line and use the equation of a straight line to figure out so here we go. It's we're just building up a picture here, and we actually need it says that, sorry, I missed out here, perpendicular. So L is passes through C, but L is perpendicular to AB. Alright, so what it means is that once we figured out the gradient of A to B, we basically need to find the equation of perpendicular bisector of A to B. That's what L is, perpendicular bisector. So the gradient of A to B is negative third, therefore the gradient of a perpendicular line is positive 3, and then we are using the midpoint formula to figure out the center of the circle. 2, 3 is the center, and finally we use this formula as we had before to figure out the gradient of the orange line here. Notice that these coordinates have to be the midpoint or the center of the circle. Okay, so don't take A or B here. These have to come from the center of the circle, which is 2 and 3. So 3 is the y value and 2 is the x value. The minus signs belong to the equation, so you have to simply copy them and work through it. So now you know the equation of L is 3x minus 3. In this next question, we've been told that a chord of a circle with center minus 3, 5, where P and Q are such and such respectively. So PQ is a chord. If you're not familiar with the name chord, let's picture it. Any two, let's pretend that I've drawn a perfect circle here, and any two coordinates, they don't have to be diametrically opposite to each other. This line connecting these 2 points on the circumference, AB, is called a chord. Now, the longest chord in a circle is the diameter, but in this case, let's call it P and Q. So PQ is just the chord. You should be familiar with the fact that the perpendicular bisector of this chord, okay, if you don't remember, this perpendicular bisector of this chord here will be where it crosses another perpendicular bisector of any other chord. So this doesn't have to be, you could this point to be Q, but it's not. Let's call this point AB. Perpendicular bisector of this line and perpendicular bisector of this line meet at the center of the circle. So we will use this assumption later in this chapter. Not quite in this example, but it's good to understand. So we're just looking at the moment, we're just looking to figure out the equation of perpendicular bisector of PQ. Alright, so once again, we're gonna go through the same steps that we did in the last example. Find the midpoint, find the gradient, take the perpendicular gradient and substitute the midpoint and the perpendicular gradient into equation of a straight line to figure out where the line L, what's the equation of line L. So midpoint, taking PQ and coordinate of PQ tells us the midpoint of PQ is 3, 8. Then We are going to work through the gradient formula, and we'll find that this is the gradient of the green line here. Okay, so its perpendicular bisector will have a half, gradient of a half. In part C, we are substituting them into equation of the straight line. We will end up with this answer here. And then we were is that look, the question doesn't show that it passes through the center. Okay, so we just proving that this perpendicular bisector of a chord is passing through this. What I told you at the beginning of the lesson, we're proving it. So if we substitute the value of the center here, minus 3 and 5, it is should satisfy the equation. What you can do is just say, all right, let's start with just the left hand side here, sorry, the right hand side, and see what it actually gives us. If I take half and multiply it by the x value and add 6.5 to it, it should give me the y value. Let's say we don't know what it is. We're not pretending, we're not setting it equal to 5, we're just working through the example. So we get negative 3 over 2, and adding 6.5 is the same as 13 over 2. Alright, so adding that, you get 10 over 2. 10 over 2 is a 5. So yeah, and 5 checks out to be the y value here. So it is correct. It does pass through the center. That's how you prove something. Alright, so in this next example, we've been told that line AB and CD are chords of the circle. They have such and such equations. So the line y equals to 3x minus 4 is perpendicular bisector of AB. So be careful here. And this line is the perpendicular bisector of CD. So find the coordinate of the circle center. So this is where you actually have to use the assumption I told you at the beginning of the lesson, where two perpendicular bisectors meet at the center of the circle. So you have to find the intersection of these two equations of the lines we've been told. We don't even know what the equation of A to B is. We don't know what the equation of C to B is. Both of these equations I've underlined are the perpendicular bisectors. So they are the equation of the green lines here. And I told you at the beginning that they meet wherever the center is. So this is just the assumption from circle theorems, that the two perpendicular bisectors meet at the center of the circle. So there we go. We just have to set these two equations equal to each other and solve them for x and y. So that's the coordinate of the center of the circle. Okay, so I leave you to practice, and I'll see you in the next video.